Can I ask one question?
I'm not sure about the recording available on YouTube, but it is available on Google Calendar itself.
It's, the recording itself is available.
Yeah.
Okay, great.
Okay, hello everyone. Good evening. Shubham, you were saying something, is it? Or
Yes, I
on
have posted a question on Discourse, although you
okay,
have answered it, but I still don't understand it. The question on
which
Discourse.
one?
It was a text like all these are so simple to do in HF. Let's do more. So the tokens means after the tokenization, the tokens the HF was tokenized as H comma hash hash F. Okay, but I have asked that there is a word let and apostrophe and S. So
Mm-hmm.
why that isn't tokenized as let comma hash hash apostrophe and hash hash S? That was
Right,
my question.
right.
And
So I answered it. So what did you understand out of that?
no, actually, I did not understand anything.
Okay.
Can you means elaborate more in the
Yeah, yeah, sure.
yes.
So, Shubham, right? One moment. I'll repeat the question for everyone to know here. Yeah. Okay. So there's a text given in the question, and bird tokenizer is what we are using. And the tokens that we are getting out of that, okay, let me share my screen probably. One moment. Okay, I hope you can see this.
Yes.
Okay, so everyone, this was Shubham's question. So there's a text that is given, and we are using Bird tokenizer and using that to encode the text, and then we are printing what we get, right? So what we are printing is the IDs and the tokens. The question is, if the word Hugging Face gets tokenized as H and hash hash F, then why does the word Let's doesn't get tokenized as this, right? So it all depends on the vocabulary of the Bird tokenizer, right? In the vocabulary of Bird tokenizer, if HF is available, if this is already available, then you will see this as a token in in this list. So since HF is getting further split into H and hash hash F, this indicates that HF as it is not present in the vocabulary of Bird tokenizer. And since let is coming, right? You're asking why let also doesn't get broken, right? Um, right. So let is a word already in the vocabulary. So let, it's a common word. No matter what data set was used to train this Bird tokenizer, in English language, this let word will be found. Let's also will be found. So that is why you see that in the list of tokens. So I actually added a code for you to check which words are present in the vocabulary of Bird tokenizer. So this is what you can make use of. This You're creating an object of Bird tokenizer, and then you want to check which of these words are present in the vocabulary. So the vocabulary you can access using this Bird tokenizer dot vocab. In general, for any tokenizer, if you want to access its vocabulary, there's an attribute. It's not a function, it's an attribute dot vocab. So you're simply checking for each word whether it is present in the vocabulary of this tokenizer or not. Let's is not present, but let is present. Since let is present, so let you see in the list of tokens, and HF is not present. That's why HF gets split into H and F. So, Shubham, are you clear with how BP algorithm works?
Yes, I think I am clear with the BP, but still means suppose we decode it back to the actual sentence using the tokens.
Mm-hmm.
How will it know that it was the whole word let's and means without the double hash? How will the tokenizer or whatever the decoder know that it
So
was the
that is why
actual
double
word?
hash is needed, right? That is why double hash is needed
Yes.
to tell it that it's not a standalone word. There is more before this S. That is why this double hash is there, right?
Yes, so in the tokens, it is let, comma, apostrophe, comma, s. There is no double hash. So my question was, how will the decoder know that it is the whole word let's and not the individual tokens? And that was I was wondering. Because for HF, because of the double hash, the decoder knows that it is H and F combined. But for
Okay.
let's, how will the decoder know?
Okay, so this is the output you're getting, is it? Okay, this code doesn't have that.
Actually, I haven't tried is using the code, but it was just in my mind, so I thought I will ask in the live session.
Okay, so you're getting a let fine and you're okay. No, this S might be already present, right? Are you asking that? Are you asking why it's not double hash S
Yes, yes,
and why it is not double hash
apostrophe, yes,
apostrophe?
whatever.
All these are so simple to do in HF. Let's do more. Okay. Why there is not a double hash here?
Yes. And without the double hash, how will the decoder know that this is a single word? That is also another question.
Okay, you would need to go into the details of how decoding actually happens.
Okay.
No, but let me reply you this very query. So I have answered how you can cross check in the vocabulary what words are present and which words are not present. But in which cases you should get a hash and in which cases you should not. Maybe let me reply to this question once again. Okay, I will get back to you on this.
Okay. Okay.
Okay. In typing the sentence, there was that's what I want to try this code. This very code I should check myself,
Okay.
uh,
Right. Yes.
and
Maybe.
then I should get back whether there was a space after let and apostrophe or not. If there is a space, then we know, right? Then we are clear. But if there is no space and still you're getting these tokens, for that you need an explanation. So let me get back to you on this thread itself. Okay.
Okay.
All right. Okay, everyone. So let's get started. All right. So let me do here. So we are going to be covering week 2 today, which is on tokenizers. So what are tokenizers? A
Tokenizer is
tokenizer. Go on, go on. Yeah.
tokenizer is basically a method
Mm-hmm.
that specifically split the uh, input sentences into some format so that machine can understand it using some coding methods or encoding methods.
Okay. All right. So tokenizer splits the given text into smaller units. These smaller units are called tokens, right? Okay. So yeah. Now these tokens can be words, they can be subwords, or they can be characters, right? In general, a token can be a word or subword. Subword means uh, a word is further divided, and character, let's say A to Z, 26 characters. So these all can be called tokens. We may use different uh, definitions of tokens in different algorithms for tokenizations that we have. Okay. So here in Hugging Face, we are going to use Hugging Face libraries. So today what we are going to use are these transformers and tokenizers. Let it get started. So we'll start from scratch. First, I'll tell you how to use pre-trained tokenizers from Hugging Face. And once that is done, then we will see how to create our own tokenizer from scratch. Okay, while it is getting started, while it is getting installed, in order to use a pre-trained tokenizer, we would need from transformers import auto tokenizer, ANT capital. And from this auto tokenizer, we are going to use a function from pre-trained. Let's give it some name. Tokenizer is equal to auto tokenizer dot from pre-trained. This is the function that we'll be using. And here we are going to give the name of the pre-trained tokenizer that we want to use. Let's say we want to use BERT base uncased. It's a variant of BERT. Uncased means it converts the capital letters into small letters. So it doesn't pay attention to case basically. capital or small, it treats them same. So this tokenizer we want to make use of. One moment. Sorry. Okay. So this tokenizer we want to make use of to tokenize some text, let's say. I'll take some example text. Let's say I'm enjoying DLP course. This is the text that we want to tokenize. In order to tokenize it, we simply pass it inside this tokenizer object that we have just now created. And whatever output we get, let's call it something, let's call it encoded. And I'm going to print this, whatever we get as an output from here. Let me so this is what we are getting from this tokenizer as an output. Now there are three things here. One is attention mask. So we are getting an attention mask of 1 for all the tokens that got created. Attention mask 1 means consider all the tokens. Attention mask 0 means ignore these tokens. By default, you will get all ones here. Input IDs. So this basically is the result of tokenization. By default, it will not provide you tokens. It will provide you an ID for each token, right? So let's say this sentence gets divided into I like DLP, these three words, let's say. So it will not return I like DLP. What it will return is some ID, some numerical, some numeric value. Let's say 30, let's say 5, let's say 45. So what these? So these are called input IDs. Input IDs are the positions of these words or tokens in the vocabulary. So this 30 indicates that in the vocabulary, 30 will be I, 5 will be like, and 45 will be DLP. So these positions are basically input IDs, which is what will be returned by the tokenizer. The third thing is token type IDs. By default, by birth, these will be all zeros. There will be a difference that will come in when, let's say, you pass a pair of sentences or pair of text. So here we are passing only one text. When you pass a pair of text, then that needs to be conveyed to the model. Then the tokens belonging to the first sentence will have a token type ID 0, and the tokens belonging to the second sentence will have token type IDs to be 1. So that is done to differentiate. By default, if you pass only one sentence, these are all going to be 0. This is the output that we are getting. Let me quickly show you what will happen if we pass, let's say, a pair to this tokenizer. We already have the object, so I need two sentences. You just copy paste this. So I have just created two sentences and I'll pass them to the tokenizer. Okay, so this is what we are getting. These are the attention masks, which will be by default 1, which means all the tokens are to be considered. These are the input IDs of these two texts, and these token type IDs will differentiate the sentence 1 and sentence 2. Okay, so this is the use of token type IDs. Okay. If you want to access the vocabulary of this tokenizer, Tokenizer dot get vocab is what you can use. It's a function. So it will return a dictionary where the keys will be the tokens and the values will be the IDs, the token IDs. So if you let me show you the few values. Let's say, let me call it something, and it's a dictionary, right? So, or let's say, let me show you everything. So vocab dot items, this will be of some type. Let me convert into a list. And once it gets converted into a list, let me show you the first 10 values. So this is how the structure of the vocabulary is, and these are the input IDs that are returned by the tokenizer. Okay, the other thing is here, how did I tokenize? I passed these two texts to this tokenizer, used it as a function. In this case, I passed this text to this tokenizer, used it as a function. Sometimes you might come across something like this, tokenizer dot encode. When you use this function encode, then this is what you get. This is what you get. So let me repeat. Earlier, this is how we encode it. We simply pass this text to this tokenizer and we got these three things. And here I'm calling this function dot encode and I'm passing the text here and this is what I'm getting. So these are the token IDs. If you simply want the token IDs, you can call this function dot encode. This suffices. There's also a function encode plus. When you call that function, then you get all the three things. Basically, all the things that you were getting earlier, you're getting all the same things, which means it's the same as calling this. So internally, when you use this tokenizer as a function, it internally calls encode plus function, which gives you all these three things. Okay. Now, this output encoded is a dictionary, as you can see, which means these are the three keys. And in case you're just interested in input IDs, you will access them like you access anything in a dictionary. Okay, so this is how you will access the input IDs only. If you want to convert these back to the tokens, then you can use the tokenizer dot decode. Earlier we used this function encode, and now we can use decode. What do you want to decode? You want to decode these input IDs. Okay, so this is what you get back. These are the special tokens that are added by the BERT tokenizer. Remember, we were using BERT tokenizer. Well, you can use any other tokenizer as well. You can use GPT-2 or any other variant of GPT-2, GPT, or any other variant of BERT, or there are several other tokenizers. For different purposes, you have different tokenizers. So depending on what you want to do, you can choose the appropriate tokenizer. So this is how you get the tokens decoded back. There's also a function tokenizer dot convert IDs to tokens in case you want to convert the IDs back into tokens. So these are the IDs that you passed and these are the tokens that you get in return. Here 101, you see 101 is assigned to CLS, a special token. 102 is assigned to this special token. and remaining are coming from the different positions in the vocabulary. Okay.
I have a question, ma'am.
Yeah.
In this, you had shown these pre-trained tokenizers. What is the vocabulary size that can be seen?
Vocabulary size you want to see.
Yeah.
Okay, the size, there's an attribute, size of vocabulary size, something. I'll have to check vocab size or something. Right. It's an attribute, it's not a function.
Okay.
So tokenizer dot vocab size will give you the number of elements in the vocabulary. Okay.
Right.
Which means these values will not be beyond this number. Right.
Right.
Okay. Okay. So this was how you can use a pre-trained tokenizer. So here we had used a variant of BERT. You can look up other variants. You can try and play around with them. We can also use GPT-2. Let me quickly show you a demo of that. Pre-trained from pre-trained. So the name is GPT-2 itself. Let's say we convert the same sentence now using GPT-2. This is our text. Now we'll write GPT-2 tokenizer. Let's use it as it is. We'll pass the text inside this. Whatever we get, let's call it encoded. Let's see what we get. Okay, this is what we are getting. Note that when we used BERT, then three things we got: attention mask input IDs and token type IDs, because BERT expects pair of, so BERT is actually more prevalently used for tasks like text summarization, right? Question answering, those kind of tasks. BERT is more prevalently used, so there's a provision of passing a pair there. GPT-2 is generally used for generator tasks. So you pass one input there, one text. That is why there is no provision of token type IDs here. You get only these two things. So these are the input IDs that we are getting. And again, you can decode them back. So in order to access the input IDs, again, you use it as a dictionary. This is what you get. Okay. All right. So this way you can.
Ma'am, can you just pass the tokens also so that we can see the special attributes for this?
What do you want me to pass?
So from the decode to like the tokens, what are the tokens? In this?
Okay, you want to see this?
Yeah, yeah.
Okay, let me copy paste this. Okay. Yeah. So by default, it doesn't add, because there is only one sentence, as you can see. The other thing that you see is the what is that continuing character, right? In case of GPT-2, the continuing character is not double hash. Double hash is a continuing character in BERT. Here you see that this G with a dot on above G. This is what is a continuing character by default in a GPT model. Okay. DLP, yeah. So this G with a dot, 1, 2, 3, 4 places you're getting. So this is the continuing character in case of any model based on GPT.
So if you have two sentences, it'll show beginning of sentence or end of sentence.
You cannot pass. Let me try it. So it doesn't allow you to pass two sentences. Let me try it. So this, what did we have? Text and text two, right?
Right.
Text two. Oh, it does. So let me see now. Uh, okay. Mm, okay. Yeah, it is accepting. Probably it is concatenating them, right? So because there's no concept of token type IDs, it is apparently concatenating them, if
Right.
I'm not wrong, because otherwise it would have differentiated them. Right now, there's no differentiation that is happening. Yeah. Okay. So this is how you can use retrained tokenizers. Another thing to note is the following, that you are, I think, introduced to BP tokenization. BP tokenization is used by GPT-2, and BERT doesn't use BP tokenization. BERT uses word piece tokenization. So there are different kinds of tokenization algorithms. BP that you would have done more extensively, probably, that is used by GPT-2. BERT uses a word piece tokenizer, and that is why the number of tokens produced by both of these might be different. Okay, that might happen. All right, there's one more thing that probably sometimes you might use. Let me, yeah, I can use any of these, BERT or GPT. Let's say you pass a batch of sentences for tokenization. Let me first create a batch. Let's say you pass a batch with sentences of unequal length. Let's say something. Let me create some sentences with unequal length. So four sentences, four texts are there. All right. So let me pass this now. You can simply pass a batch the way you were passing one sentence. At the same way, you can pass the batch. Right. Now, if you see, the number of tokens for each text might be different. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So for the first two, it's 6, and for the last two, the number of tokens is 7. When you pass a batch, then you want the length of each text to be same, right? In that case, while you are tokenizing, you can pass, you can ask it to pad to manage the unequal lengths. So now, after I passed padding to be true, which is by default false, you are getting a 0 token in order to make the length of all the sentences in the batch to be equal. And also, you're getting attention mask. In the attention mask, you're getting zeros here, which indicates you ignore whatever is there here. Okay. That is one thing. There's one more parameter that sometimes you might need, which is truncation. Okay, let me try showing that here itself. So truncation is also by default false. Let me pass truncation to be true. But with truncation, you also need a max length. So there's always a max length with each uh, model. So let's say, I think it's in GPT-2, it's 512. Here, let me try passing a smaller length. Let's say 1, 2, 3, 4, 5, 5. We pass 5 here. I'm just like that reducing the length of a few texts to demonstrate something. Okay, let me see if I get the right output. Okay, correct. So padding you understood earlier. Now truncation I've set to be true, and I'm saying that max length to be 5. So even if some tokens are getting truncated, but uh, we will follow this max length. So earlier, for last two tokens, the length was 7. After I set truncation to be true, now they are reduced to 5 length. So this here you see both padding as well as this is for padding, and truncation has happened here. So these two are important parameters.
What is the token type IDs here? Means what does it signify?
Yeah. So here by default token type IDs will be 0. In case of BERT, in case of so when you pass a pair of sentences, right? When you pass a pair of sentences, then you want let's say this is a question and this is an answer, right? And they will be separated by some separator. uh, so you want to indicate that this is a question and this is an answer, or let's say this is the paragraph and this is a summary, right? So you're basically passing a pair. In that case, all the tokens corresponding to the first text will be 0, and all the tokens corresponding to the next second sentence will be 1. Okay, that's how we differentiate. Otherwise, by default, the token type IDs will be 0. Okay.
So in GPT, it will always be 0 for GPT.
Yes, it will be 0.
Means if it is a, it if it is always 0, then why it is printing? Means what is the use if it is always 0?
Yeah, you can skip it. Why it is printing if it is not needed? So yeah.
In GPT, it's not printing token IDs, I think.
So here we are using tokenizer. We are using tokenizer, and tokenizer is an object. Okay, tokenizer is the first one.
Okay, okay, okay.
Tokenizer is the first one, correct? Yeah.
For the
Tokenizer
bird.
is BERT. Tokenizer is
Okay,
BERT,
okay,
right?
right.
Right, correct. And GPT-2 tokenizer is for GPT-2, and there it is not printing these, right? Okay.
Yes.
All
So,
right. So yeah.
one question, ma'am. This truncation, I didn't completely understand. So, if there's a sentence is longer than
Hmm.
words, then what happens? It cuts it to full length 5?
Yes.
Okay,
It will ignore the last beyond the max length limit.
I see.
It happens, right? In ChatGPT also, let's say
Right.
you
Yes, ma'am.
give a huge text, it will truncate, right? It will not accept beyond the limit, whatever is its limit. Okay.
Right.
All right. So this was about using pre-trained tokenizers, and I hope you understood. You simply have to make use of this auto tokenizer dot from pre-trained, and here you pass the name. Now, sometimes you would want to create your own tokenizer. Okay. In order to create a custom tokenizer, let's say, your text is specific, your task is specific, and no already existing pre-trained model is doing a good job with your specific problem. In that case, you would want to create your own tokenizer. There are some couple of steps that you need to follow for that. So let me start off with the simplest one. So you would need to train your tokenizer. So for that, you would need some text. Let me start off with some example text, and then we will make it more complicated. Let me copy paste this, whatever I had created. This thing is it. Okay. This is very simple actually, but it's okay. We just want to understand the process. Some text we have in the form of a list, let's say. In order to create a custom tokenizer, we generally follow some 3-4 steps. All of them are not mandatory, but sorry, yeah. You might want to normalize your text, this text. You might want to normalize. I'll tell you what all may come under that. You might want to use a pre-tokenizer, and then finally you need to use a model, or you can say algorithm, which could be VP or word piece or whichever, or sentence piece, or whichever algorithm you want to use. Finally, a post processor. This is the mandatory step. The rest three are actually, I think these two are mandatory. Normalizer is optional, post processor is optional. So in order to create a custom tokenizer, you can use these two steps. Okay, what these are? Normalizer. If you want to normalize your text, for example, you want to convert the capital cases to small cases, that kind of normalization you want to perform, you can do that as the first step on this data. If you don't want to do that, you want to keep the cases as it is, for example, you know, NLP and NLP, these two you want to use, you want to differentiate between them, then you might not want to convert them into a small case before training. So it's up to you whether you want to use it or not. Then pre-tokenizer. Before you use the tokenization algorithm, you might want to split your input text, this text. You might want to split that based on some criteria. Let's say white space. That's the most commonly used. White space, wherever white space is there, you split based on that. So that will be the bare minimum, very basic splitting. Okay, that's what is done by pre-tokenizer. You can split based on anything. Let's say you want to split based on punctuation marks. Here, these are very small, but you imagine huge paragraphs here, right? So there you might want to split based on some criteria, either white space or a punctuation mark or a couple of other criteria. You can use a custom. You can use your own custom pre-tokenizer, right? Then you will specify the model and post processor. After the input, getting the input from this algorithm, how do you want to display that? For example, you might want to add some special tokens. For example, if it's a pair, then you want to separate them by a special token, let's say SCP for separator. And if this is only one sentence, then what should be the beginning token, what should be the ending token. So all that, if you want to do something special, you can use post processor. If you don't want to do that, there's no need to use this. Okay, so in order to do these four steps, you would need some classes which are present in tokenizers. We imported, did we not? Tokenizers we had installed. Yeah, that is fine. Okay. From tokenizers, what all you would need are the following. Tokenizer class with a capital T. Models will contain these models, VP, word piece, sentence piece. They will be there in this models. Pre-tokenizers will have several pre-tokenizers, for example, white space or punctuation marks or whatever. Then finally, in order to train your tokenizer, you would need trainers. These are what you need to import. Then you first need to create an object of this, an object of a model. Pre-processing, post-processing, we will add to that. So tokenizer is equal to tokenizer with a capital T. We're basically creating an object of this. And in the parameter, you need to pass which model you want to use. So models dot, let's say we want to use BPE. We'll pass that model here. And there's a parameter UNK token, unknown token, which means if there is a, while tokenizing in the given text, if you find a token which is not there in the vocabulary of the model, then how it should be handled. So we are saying you replace it by this token. Okay, it's an important I mean, you should not skip it, you should pass it, otherwise the model will get confused if it comes across a token which is not there in its vocabulary. it won't understand how to take care of that. Probably it will either ignore, or it'll not actually keep it, it'll ignore it. So you should use this. Okay, so this is a tokenizer object. Now now to this we can add a normalizer, we can add a pre-tokenizer, we can add a post processor. So if you want to add a normalizer, tokenizer dot normalizers. Let's say you want to convert everything to lowercase before anything starts. Tokenizer. So this is an object that we just now created, this very object. To this, we will keep adding a normalizer, a pre-tokenizer, and a pre-post processor. So tokenizer dot normalizer is equal to lowercase sorry, from tokenizer dot normalizers import lowercase. Tokenizers, from tokenizers. It's a tokenizers. It's not tokenizer, it's tokenizers. From tokenizers dot normalizers. Yeah. So we have just now added one thing, which is normalizer. Now we'll add a pre-tokenizer. Tokenizer, which is our object, dot pre-tokenizer. Pre-tokenizers dot white space. So we want to split our given text based on white space. You can look up, there's something called punctuation and a couple of other things. Now these tokens should be passed to the model. For that, we need to train using a trainer. So trainer is equal to this trainers we imported, right? So we are going to make use of this in order to train our model. So trainer is equal to trainers dot DPE trainer. You know, to if you want to do word piece if you want to use word piece, then there'll be a word piece trainer over here. DPE trainers. Now there are a couple of things that will pass here. First thing that will pass will be vocabulary size. Okay. You can give it any size, but for demonstration, I'll keep it a small one. Anyway, our data is also very small here. This is a very small data set, so I'll go with 50 here. Special tokens, which means the tokens that you want to add to your vocabulary. You want to reserve them, you want to keep them already in your vocabulary. A list of those special tokens you will be passing. We want to keep unknown token. For classification, we want to keep a CLS. For separating, we would want a separator. And let's say for masking, we need a mask. So these are some commonly used special tokens that are used. Another is continuing subword prefix. Continuing subword prefix, which is double hash in case of DPE. Okay. So this is a trainer that we have created for our tokenizer, which we'll be using for training. In case you want to add a post processor, you can create. So just like we added a pre-tokenizer, same way we'll add a tokenizer dot post processor. You can skip it if you don't want it. Well, for this you need what is called template processing. Template processing. which you would need to import from tokenizers dot processors import template processing. This template processing is used to create a template for your output. So for example, here you can mention that if there is a single input, how should that be given out? We want to say that the first token should be a CLS followed by whatever tokens we have, and the last token should be a separator. That's how a single text should be handled. In case we are passing a pair, how that should be handled? Let's say we want a CLS in the beginning, followed by the tokens of the first sentence, and then a separator, and then a token, the tokens of the second sentence. Here, I think you can give an ID also, but we'll check. Okay. Another thing that you can pass is special tokens. Whatever special tokens you are going to use, there's a list that will work here. You can also give the IDs that should be assigned to CLS. For example, earlier you saw that 101 was being assigned, right? CLS and separator. So CLS had a 101 and separator has a 102. So they are reserved. Similarly, here also we can reserve, let's say, 2 and 3 for special tokens. CLS, you want it to be, let's say, an ID of 2, and similarly a tuple for separator, you want it to be having an ID of 3. Okay, so you can have any number here, whatever you want. Okay, so we have defined our normalizer, pre-tokenizer, and post-processor. All the 4 steps we are done with. The only step that remains is training. So tokenizer dot train from iterator. It's a function in tokenizer, train from iterator, which means here you should have an iterator. In our case, our data is in this list. List, is an iterator already. So this is what I'm passing here. The second thing will be the trainer that we have already created. So we want to use this trainer on using this text data. Once the tokenizer has been trained, we can save it. We can save the file using a JSON file. Let's give it some name. Let's say custom BP tokenizer.json. Let's see. Okay, so this has been created. This JSON file has been created. So whenever we want to make use of this tokenizer, we can load it, and then we can make use of this. For example, let's load from here. Although we have this tokenizer, we can directly make use of it. But let's say, the other day we want to use this tokenizer. So tokenizer dot from file is a function that you can make use of to say that we want to read from this file. Okay, let me call it something. BB tokenizer is equal to this. So I have read this from the file. And let's say now we have some sentence which we want to tokenize using this tokenizer. Let's say tokenization. So this sentence we want to tokenize. So I'll just use this BP tokenizer, and I can call this encode function to encode this sentence. Okay. In case of pre-trained tokenizer, you know how the output was coming out to be. We were getting those three things, right? In case of a tokenizer that we create from scratch, this is the kind of output that we get. Firstly, what we are getting is the number of tokens that will be produced for this sentence after learning from this data, this bare minimum data we learned from, and we get 30 tokens. Let's print that also. These are the tokens that will get produced. These are the IDs, basically IDs of the tokens that will get produced. Let me see if, okay, it shows like this only, no problem. So these are the IDs, and if you want to see the tokens, these are the tokens that you will be getting. Okay. This is not a very good tokenizer because the data set is only this much. Of course, we can use any other, a real data set for training that we will see later. But for now, this gets produced as tokens. And the other thing is, so when we print this encoded, we see the number of tokens and the attributes. There are several things that we get from this encoding. IDs is what contains the token IDs, which you can access like this. Then type IDs are there, then tokens are there, then a couple of other things. Attention mask is there, offset, special tokens, mask, and a couple of things are there. You can experiment with that. Okay. So these are the tokens that get produced. There's one more thing which is optional if you want to do. If you want the output to come out like how a pre-trained tokenizer's output is shown, if you want to do that, then there's a class that you can make use of from transformers import pre-trained tokenizer fast. So it's kind of it will create kind of a wrapper for you. Okay, wrapper for the custom tokenizer that you have just now created. So let's see how things will change. Pre-trained tokenizer fast, you'll create an object of that. And here what you will pass is your tokenizer file, the JSON file. Which was this thing. I'm going to pass this. Unknown token. And in case you want padding, you can optionally pass a pad token. Okay. Now this is important. Model input names, which is what should be passed to a model, which is what you want as an output from the tokenizer when you call the encode function. Model input names will pass a list of all that we are interested in. What we are interested in are input IDs and token type IDs and attention mask, let's say. Okay, I think that's it. So basically, we have passed this to this file to this class. Now, if you make use of this tokenizer, in order to tokenize your sentence. What was the sentence? The sentence itself, right? So I'll pass the sentence here. Sentence. And whatever is the output, let me call it this, and let me print that now. So we are getting the kind of output that our pre-trained tokenizer was giving us, which is attention mask and input IDs and token type IDs, and in the form of a dictionary. Exactly the same format we are getting now. If you're not interested in, if you're not very particular about getting in this format, there's no need of using this. You can just continue using your tokenizer the previous way. Simply, you can access the IDs and tokens like this. If this is okay for your work, you can continue like that. Okay, so this is a very simple tokenizer that we have created. Here, as you can see, we used a very small data set, which doesn't make much sense, but I just wanted to get you started into creating a custom tokenizer. We generally use a data set, a real data set, in order to train our tokenizer. Data sets, I think you're already aware of how to load a data set from Hugging Face. There are several data sets that we have. Let me quickly show you how in the same scenario, if you want to use a real data set. So you're going to import some data set using load data set, which you might have done all that. In this load data set, you will have to pass the name of a data set that you would like to use. This Colab has some limited resources, as we know. So we would like to use a small data set. So there's one that I know is small. So I'm going to use this one. So a version of this data set is also, we would pass. It has several versions. V1 is what we want to use. Then you would mention split, which split you want to use. So train is what we can pass. Okay, let's say, okay, this data set I think will be manageable. All the training data set will be manageable in Colab, with Colab resources. But just let's say you are using some data set which is huge. So what you can quickly do is you can mention that I would want initial 1% of the data. So that's, I think, a quick shortcut to make use of a data set which cannot be managed with your resources, and you want a piece of that data. So this way you can get 1% data. Let's say text, we call it. And there's a feature text, which is what I'm interested in. So it's just fetching the 1% of the data. By the way, if you want to see the size of a data, so that also you can quickly check. Size in bytes, you can check. Size in data set. So this is what I loaded. So I'm using this attribute size in bytes. This is the size in bytes. If you want to, let's say, see in GBs, so there should be GBs. This is the size of 1%. Please note, this is 1%. So you multiply it by 100. So that much GB. So as you can see, it's a small data set, very much doable for a demonstration. You can have actually downloaded the entire data. That would be okay as well. You can also see how many samples are there. So you can simply do this length of data set that will give you how many samples are there. 367. This is 1%. So 367,000 samples basically in the entire data set. Good for practicing. Okay. Now we would want to train our model on this data set, right? I think we can use the same code. Everything else should be okay. So vocab size earlier was 50, right? Which is very small. So we would want to increase it. Let's say I would make it 5,000 or so. Let me make it here itself, or let me copy paste this code. Yeah, all this I will reuse. So okay, this is our data, and everything else remains same. We will use BP, and lowercase is fine, white space is fine. This I'll make up 5,000. Okay, and special tokens, let it be same, and this let be same. So let me call it 2. Okay, so now our data will be Wikipedia text. Okay, Wikipedia text, and trainer will be this, and this is tokenizer 2, right? Tokenizer 2 train from iterator. We call it 2, tokenizer 2 dot save. Okay, so this gets created. Now I'll use the same sentence. Now you see 13 tokens. I hope the trade-off between, this thing and this thing is understood. See, earlier we had a vocab size of only 50. A smaller vocabulary size leads to a bigger, larger number of tokens, more number of tokens when you tokenize the same sentence. So we use the same sentence in both cases. Earlier we had 30, how many? I think 30 tokens. 30 tokens earlier when the vocabulary size was 50. So you can understand, let's say, vocabulary is character level, A, B, C up to Z. So it's 26. So vocabulary size is small. When you use this vocabulary to convert a text, I like NLP. It's a character level vocabulary when you use it to tokenize this. So ILIKE NLP, right? So 8. Small vocabulary size 8. And on the other hand, let's say you have some words in this vocabulary, so that will increase the size of the vocabulary, in which case, let's say I is a token, like is a token, NLP is a token, so this is resulting into 3. So there's a trade-off. Less vocabulary size, more number of tokens in any thing you tokenize, and more vocabulary size will result into lesser size, so lesser number of tokens, right? It's not a good idea to have a lot of tokens in every text, because that will slow down things, right? The model will become very slow if there are a lot of tokens in your text. So that's why character level vocabulary is not a good idea. Okay. All right. So yeah, we can see this also. These are the IDs. Again, you can wrap it using uh, this thing. Using pre-trained tokenizer fast, you can just make use of it once again to wrap your to get a wrapper for your tokenizer. Okay, so these are the tokens that get created. So this is the custom tokenizer that we have created. Any doubts now? Any doubts in what we did?
How did you wrap that?
Yeah, so I just made use of this this class pre-trained tokenizer fast. There is one more, pre-trained tokenizer and pre-trained tokenizer fast. So this, as the name indicates, is faster. You can get to know, you can see the exact differences between the two in the documentation. So I just created an object of this class where I pass the JSON file of the tokenizer that we had just now created, and I pass the unknown token and pad token optionally. And this is important. What is it that I want uh, to be displayed whenever I am using this tokenizer? In this encoded, what all I want to display. So these three things get displayed whenever we use any pre-trained tokenizer. So that's why I pass these three things. And this is what we get. So now the output of our tokenizer is exactly the same what we get from a pre-trained tokenizer.
This pre-trained, how's it reading the JSON file? Huh?
How is that reading? Is sorry, I didn't get your question.
So you've defined tokenizer file. You saved that on your
Yeah, we
local.
saved, right? Yeah. I showed it here, right? So when you do tokenizer dot save, so it gets saved here, which is what I read from,
Okay.
right? Okay. All right. So this was, I think, pretty much whatever is covered in your week 2, and I think you'll be able to finish
So
your assignment.
one
Yeah.
question: you don't have to give the path in this of your.
Here it is. So here, uh, wherever I'm working,
Right.
there itself, this file will get created. Right? If you want, let's say you're working on your local system, and here you can give path where this file should get saved. And again, when you are making use of it, then you will have to give path.
Give the path. Okay.
Yeah.
And there also in the fast train also you'll have to give the path then again.
Yes, definitely.
Okay.
Yes. Yeah. Okay. So I hope this was clear. If you have any doubts, please go ahead. Otherwise, in this course, you can post. This is not getting streamed, is it? But then it's not getting streamed, is it? Why
Uh,
it's getting streamed?
I think it is
It
the
is.
symbol is there.
I see the problem, Manamika. I think it is not started with the course ID. That's why it's not uh,
Oh no.
streamed to.
Oh, I started it, is it?
Yes. So what we can do, we can provide the. Is it recorded or not? Let me check. If it is recorded, we can.
Recording is there? Okay, good then. Yeah, then we will upload it, Chaitanya.
We can upload it later.
So you had to start it from course ID, right, Nitin?
Yes, I should have started
Okay.
it.
Thank God it's getting recorded. Anyway, so we will upload it then. No problem.
So when will this be uploaded, ma'am? Because I
By
like to.
tomorrow? Is this
Okay.
okay?
Yeah.
Yeah.
Ma'am, I have a very naive doubt about.
Go ahead.
Ma'am, there are already good tokenizers available like GPT-2 and Uncaged Bird, right? With like 30,000 or 32,000 vocabulary size.
Right.
So why is there a need of a custom
Good question.
tokenizer?
So I told you, right? So see, we just now spoke about text data, right? In general, your data set could be, firstly, it can be speech data, it can be image data, right? Of course, there are tokenizers available for speech data and image data, but sometimes your data may be, I don't know, very different. Um, so text, so some standard formats are there, right? But your data can be very specific in some cases, and your model might have specific requirements about how, which kind of tokenization will work the best. So the inbuilt, the pre-trained tokenizers might not be sufficient for that. For simple text processing, these tokenizers are good enough actually. But you are taught to create a custom tokenizer just in case you work on a project where there's a very specific kind of data. And in fact, you might be working on a project where you would be training your own model, right? Let's say you have all these resources, GPU resources and memory. You might be creating your own model, you might be training your own model. So tokenizer is always coupled with the model, please note that. For that matter, if you're using a BERT model, you should use a BERT tokenizer. If you're using uh, uh, if you're using a GPT model, then you should use a GPT tokenizer. That's one thing. So if you are creating your own, if you're training your own model for a very specific scenario, then you might need a very specific tokenizer, which none of the existing pre-trained tokenizers might be sufficient for. Okay. So Jalaj, yeah.
Right, ma'am. And indeed, and then one more question I had. So, this tokenization of text, so we are basically creating some kind of embedding that will be our input to transformers, right?
Yeah, embedding will be created after this, Jalaj. Tokenization is the first step. After this, the embedding will take place.
Okay.
You
Right.
need, for embedding, you first need the tokens, right?
Right.
Right. I mean, if you are not using tokenization, then the simplest thing that you would use is a white space separator. That's the bare minimum thing. I think that's what people were using earlier before these tokenizers came into picture, right? So that was the bare minimum, that you would separate all the words by the white space simply, and you will pass them for embedding. Okay, which
Right.
was not the best way, as you know. You know, that can result into huge vocabulary, and words like study, studying, and so on may be treated differently. So that's a waste. They're not understanding the context. That's why tokenizers are there.
Right, ma'am. So tokens will go into the embedding, and then embedding will go into the transformers. Right?
Yes, yes,
As input. Okay.
exactly.
Thank you.
Okay. Any other doubts? All right, then. All right, if you still have any doubts, please post on Discourse, and that one question I will get back on Discourse itself. Thanks, everyone. Take care.
Thank you.
Thank
I,
you.
I didn't have a doubt, but I just wanted to point out that the NPP3, the dates are from March 21st till March 23rd, and
Oh, is it?
it's clashing with the NPTEL exam dates.
Okay, okay.
So
It will be in week 12. Okay. But if there's a clash, then we will reschedule it. Archit?
yeah,
Okay, we will see this, Archit. We will revise the dates, no problem.
all right, thank you.
Yeah, okay. Okay, thanks everyone. Take care.